Good day, everyone. Welcome to ICCT Online Learning. For this day, let us proceed to the next chapter, that is gas laws. Now, gas laws, so the various laws governing the behavior of gases. Then second, so gas laws, which is the law relate to the pressure, volume, and temperature of a gas. Then third, so gas laws are inconsistent with the kinetic molecular theory as applied to gases. Now, we have also some observable properties of gases. Number one, gases exert pressure, wherein pressure is exerted equally in all directions by a gas container. Second, gas expand. A certain amount of gas fills uniformly any size of container. And the third, gases are highly compressible, which is the volume of any gas can be decreased greatly by increasing the pressure exerted on the gas. So meaning there is a relationship between the volume and the pressure exerted on the gas. Now, for that, so I have here the simple illustration between the relationship of pressure and volume, just like in this figure. So we have the first illustration recognizes a certain pressure and a certain amount of volume in this first part. Okay. Then in this one, we have here a certain pressure amount with a certain amount of volume. And then after we push this particular piston in the second illustration, so if we push it just like this one going down, so if you notice, the cylinder will decrease its volume, but the pressure will increase. So that is the relationship between the volume and pressure of a certain amount of gas. Meaning, if you take a look this particular illustration, so we observe that as pressure increase, the volume will be decreased. Or as pressure decrease, the volume will be increased. So meaning their relationship are inversely proportional. Now, for that, so we have here what we call some well-known laws in terms of gas. That is what we call the Boyle's law. So for the Boyle's law, so it is the relationship between pressure and volume. Second, so pressure and volume are inversely related. Third, the law states that the volume V of a gas or a sample of gas changes inversely with the pressure of the gas as long as the temperature and the amount of gas remain constant. So meaning, if there is a changes between the relationship in pressure and volume, the amount of temperature will be constant. Now, in relate with that particular parameter, so we have here the formula for the Boyle's law. The formula is P1V1 is equal to P2V2, or just simply initial and final volume, which is equivalent to final pressure multiplied by final volume. Again, initial pressure multiplied by initial volume, which is equivalent to final pressure times final volume. Okay? Now, another we have Charles' law, another well-known law, that is a Charles' law. So that is the relation between volume and temperature. So the law states that the Kelvin temperature and the volume of a gas are directly related when there is no change in pressure or amount of gas. Then the third bullet, so the volume is directly proportional to the Kelvin temperature at constant pressure. So meaning the relationship between volume at the same time temperature are directly proportional, and there is no change in pressure. So meaning the amount of pressure is constant. Now we have here the formula for the Charles law. So we have B1 all over T1, which is equivalent to B2 all over T2, or initial volume divided by initial temperature, which is equivalent to final volume divided by final temperature. But take note that temperature should be expressed in absolute temperature, wherein the unit is Kelvin. Okay, so we need to use the absolute temperature in Kelvin in solving this particular law, that is Charles' law. So we need to use Kelvin temperature for initial and final temperature. Okay? Now, for that, so we have here some example in regards to Boyle's law and Charles' law. So for the first example, so a gas sample exert a pressure of 3.0 kilopascal when it occupies a 12.0 liter vessel at 20 degrees Celsius. Now, the question, what pressure will be or will the gas exert at 20 degrees Celsius if the same gas sample is transferred to a 9.0 liter vessel? Okay, so in this problem number 1 or in the first problem, so if you notice, we have 3.0 kilopascal, then we have 12.0 liter. Obviously, that is both pressure and volume respectively, but that is an initial pressure and initial volume. Then we have a 20 degrees Celsius in that particular initial pressure and volume. At the same time, after taking the pressure at the same gas, so if you notice that the temperature is also the same. So meaning, this particular problem is signifies to Boyle's law because if you notice, the temperature are constant. Okay, and then again, we need to determine what is the pressure with a 9.0 liter vessel. Now, to solve this problem, so we have here the solution. So we have the value of P1, that is 3.0 kilopascal, B1, that is 12.0 liter, B sub 2, that is 9.0 liter, and P2, that is unknown. Then after that, so we will use the formula of Boyle's law. So P1 B1 equals P2 B2. And then if you derive the formula to get P2 or the final pressure, you will come up with this. So P2 equals P1 B1 all over B2. Then just simply substitute the given values. So P2 is equal to 3.0 kilopascal multiplied by 12.0 liter divided by 9.0 liter. Then after that, so just simply solve, you will come up with P2 is equal to 4.0 kilopascal. Okay, so that is the final answer for number 1 under Boyle's law. Okay, next, another example. So let us try this one. A gas sample is observed to occupy 12.0 liter under a pressure of 101.325 kilopascal, also 1 atmospheric pressure at 27 degrees Celsius. What will be the volume of the gas if it is heated to 57 degrees Celsius under same pressure? Now, if you notice in this problem, so obviously it says under same pressure. So meaning, this particular problem is under Charles' law. At the same time, if you notice the temperature, it will change from 27, it will become 57. So that's why you need to use the formula under Charles' law. But before that, we need to identify first the given. For the given, so we have T1 that is 27 degrees Celsius, B1 that is 12.0 liter, T2 that is 57 degrees Celsius, and we need to determine what is the final volume. Now, the next step is, again, as we said earlier, we need to form the temperature in the form of Kelvin or just simply in the absolute temperature. So we need to express temperatures in absolute temperature in Kelvin. So that's why we need to convert temperature 1 and temperature 2 by Kelvin. Just simply the temperature or the degrees Celsius, both T1 and T2, we need to add it by 273. So for T1, so we have 27 degrees Celsius plus 273, we will have 300 Kelvin. And for T sub 2, that is 57 degrees Celsius plus 273 equals 330 Kelvin. Okay, after expressing the temperature into Kelvin, that's the time we can now use the formula of Charles' law. And then since we need to determine what is the value of B2, so if you derive the formula, you will come up with this. Okay, so it will become B2 equals P1 times T2 all over T1. Then after that, so just simply substitute the given values. So B2 is equal to 12.0 liter times 330 Kelvin divided by 300 Kelvin. Then after substituting the given values, you will come up with the final answer, 13.2 liter. So that is the final answer for that problem. Okay, so again, the answer is 13.2 liter. Okay, so for that, so thank you for watching and hope to see you in our next video. So goodbye and have a good day, everyone.
For more ICCT College's video updates, please subscribe and click the notification button.